Hi everyone, we are Felt Labs, and in this video we will present our Federated Anomaly Detection project, which is submission for Singapore Blockchain Innovation Challenge. So let's start with what's anomaly detection. In many different areas, we want to detect outliers. It's quite a common problem. For example, in production lines, we want to detect faulty products. We want to detect frauds in online shopping or bank transactions. We want to monitor servers running and detect any kind of faults. Also, in cybersecurity, we want to detect any potential attack. And all of this could be the case of anomaly detection. To further imagine this problem, let's say that we have 3 different companies, and each of them are producing some product, let's say cars, mobile phones, or any other electronics. They want to detect if their products are faulty or the one product which is produced out of the line is faulty or not. And each of the companies could do it on site at their factory, but generally speaking, it's better to have more data if you want to detect outliers, because if you are detecting outliers only at one of the facilities, maybe they are producing a lot of bad products, and then it's really hard to spot that they are actually outliers. So it's better to use the data aggregated across all of the companies. But in such case, we would need central server where all of the companies are sending their data, and the data are validated on this server. The issue with that is that all of the data are revealed to the central server, and this can be problematic because of some privacy or security issues, and the companies might not be willing to reveal all of their data. So can we do it better? And we can do this decentralized case. And in this case, each of the companies are storing the data on their side and running some pre-computations. These are then aggregated together. Still, the aggregation has to happen on some server, but it can be done in such a way that the server aggregating these intermediate results actually doesn't find out anything about the original data or even the final result. So once these intermediate results from all of the companies are aggregated, they can be sent back to the companies, and each of them can validate their products on site. This all can be done because we can calculate these statistics accurately and securely using things like encryption and multi-party computation. And the good thing is that all data remains to the companies, and it doesn't have to be shared with some central server. So actually, what's Felt doing in all of this? Felt is a tool for data science on distributed data. We allow you to train machine learning models or compute some basic statistics on distributed data, and all that can be done without compromising the privacy of the data. And for that, we are using Ocean Protocol, which is a blockchain-based tool for data marketplace and data management. And one of the cool things it's provided by Ocean is the compute data access, which allows you to run computations on data without actually seeing the data. And this is used a lot in Felt. Without further ado, let's go to the demo part of this presentation. We will be using this wire production data obtained from Kaggle, and we'll present how our tool can be used to solve this anomaly detection problem. So let's go ahead and start with the demo part of this presentation. For that, we will be following the nodes described in this anomaly detection repository, and you can find link in the description and open it up for yourself. But if you scroll down here, there is some descriptions and basic information. And in this video, we'll mainly follow the usage decentralized. What it does is that we already published some datasets on Ocean Protocol. We'll be using the Polygon Mumbai testnet, and we will execute the training in the decentralized setting and then evaluate the final model on one of the datasets. So let's go ahead and start by opening up the Felt Labs application. You can click on this link and open up a new window. And usually when you open the Felt Labs application, you will start on the home screen. And first thing you have to do is connect your MetaMask account. So I already had this set up, so it will automatically connect, and we have the Mumbai testnet selected as the network. And I will also activate this automation, which will make things a little bit easier for us. And this will use a special account for automation. And we will select this multiple dataset option because we want to compute some statistics on multiple datasets which are decentralized. And we will start by naming this training, call it Anomaly Detection. And we have to pick some datasets which we want to use. And for this, we already published the datasets. You see that there are 3 DIDs. And if you open one of them, let's open the first one, it will open up the Ocean Marketplace, and we see that there is the cable production part 1, so you can imagine it as the data from first factory. And these are published on Ocean Protocol, so they are stored on chain on one of the Ocean providers. And if you scroll down, there is the DID, which is the unique identifier of the dataset, so we will copy that and paste it in the application. And we'll do the same for the other 2 datasets. So we just copy the DIDs, which we already provided. And the last one. And in the application, you can even view that we really selected the correct dataset, which is the cable production part 2 and 3 as well. And then we can go to the next step. In the next step, we want to pick what kind of machine learning model or analytics we want to calculate. So we will go to the analytics section and we will pick mean and standard deviation, which we will need for later part of this presentation. Let's click on next step. And in the next step, we just have to select which column we want to use for calculating these statistics. And we will leave it to the -1, which represents the last column of our data. Then we just have to click submit, which will start the training process and start the compute jobs on each of the datasets separately, calculating the local results. This starting process can take a while, depending on how fast are the transactions processed. So we will just fast forward to the end of this process to make the video a little bit shorter. And once this is finished, we can proceed to the next section. So just click finish and go to the launch jobs. So in the launch jobs, we see that there is the anomaly detection job which we started. And we just need to reload the status of these compute jobs. And we see that each of the compute jobs, which we started for each of the datasets separately, already finished. And now we can just aggregate the results of each of these compute jobs into the final model. So we click on aggregate and once again wait for the compute job to start. So we just have to process few transactions on a blockchain to start the computation and then wait for the result. So once again, we will fast forward this process. And we are finished as well. So now we just click finish and we have to wait for this aggregation. So we click reload and this will update the status of the computation. So just click reload a few more times. Now once the aggregation is finished, you can click on download final model, which in our case is just the values of the mean and standard deviation calculated on all of these 3 datasets all together. And with this, we can proceed to the next section. So in the next section, once we have this final model, we actually want to use this model to check for some anomalies or outliers in the datasets we have. So we will open up the application once again. We'll go to the app, health labs, and /experimental. So it's still quite a new feature right now. And once again, we need to connect the MetaMask and activate the automation. So we will name this detection. So it will be the inference on the data. And we will use the first data set we have. So we'll just copy the ID. And for the algorithm, we already had that published as well. So in the evaluation of our model, you see the algorithm and there is the DID. And for the algorithm, you can actually find the source code here in the repository. So if you go to the source and detection algorithm, you will see that the algorithm is quite simple. All it does is that first load the model, it loads the data, and then it will calculate this Z-score, how far from the mean the value is and then divide it by standard deviation. And if this is higher than 2, we'll just call this anomaly or outlier and we'll create some chart from it. So let's go back to the application where we will start the algorithm on this dataset. We uploaded the model, so the one we downloaded, we just open it and pick the final model anomaly detection. And we click run. This will once again start the compute job on the dataset we selected. Once the compute job starts, we can go to the section with the jobs which we started, and we see the detection here. Once again, at first it's the warming up status, and we just have to reload the status to see at what stage it is. And we see that the algorithm finished successfully. And in the actions, we see there is multiple files which are output of this algorithm. And we can pick one of them which we want to download. So we will download this result and hit download. And this will download the final image, which is the chart which we calculated. And we see that on our data, we find 2 outliers. One is at period 1 and one at period 5. And that's basically it, what this anomaly detection demo does. Obviously, we could improve on the UI, make it a bit nicer that we don't output images, but show it in the application itself. But I think this is for the demonstration of how you can use felt labs to calculate statistics across different data sets which are decentralized, and then use the final output for something useful as this outlier detection or something else. So hope you find this interesting and thank you for watching.